Welcome to today's Explainer. We're diving straight into a really wild story today, literally tracing the DNA of how we organize human knowledge. It is kind of crazy to think about, but the exact same mathematical equation sketched out in a cramped Stanford dorm room back in the 90s? That's fundamentally the engine powering the massive AI cognitive grids that are completely rewiring our world right now. So let's just get right into it. To really grasp where we are today, we kind of have to rewind to this profound structural crisis of the early web. So picture early 1998. The internet is this massive, rapidly expanding ocean of text, but it was paralyzed. The big legacy portals of the time, we're talking multi-billion-dollar monopolies like Yahoo and Excite, they treated the internet like a flat, disconnected supermarket ledger. It was basically turning into this vast, unmapped desert of data noise. Humanity had managed to build this incredible global library, but we just didn't have the math to filter the truth from the absolute garbage.
Okay, let's dive into exactly why that was happening. The early method of finding things was incredibly vulnerable to manipulation. Those old-school directories relied on simplistic, text-based keyword counting. And opportunistic commercial actors, they figured out how to game this instantly through a practice called keyword stuffing. They'd just pack invisible metadata lines with thousands of hidden, repetitive words. So imagine you're searching for a crucial academic medical report, and instead you get dragged straight into a sketchy ad farm or some completely irrelevant directory. That was the 1998 Internet experience in a nutshell.
Section 1. The PageRank Revolution.
Now, this revolution absolutely didn't happen in some slick corporate boardroom. It happened in a messy Stanford computer science lab with two 24-year-old PhD students, Larry Page and Sergey Brin. They looked at the web not as a commercial media portal, but as this dynamic mathematical graph. And Larry Page made this definitive cognitive leap. He realized the web's linking patterns perfectly mirrored the academic peer review system. His exact quote is brilliant. Every single hyperlink on the web functioned as a voluntary, democratic vote of intellectual citation. You know, in academia, a paper is valuable if other elite papers cite it in their footnotes. So Page and his brilliant partner Sergey Brin resolved to map that exact citation graph across the entire topography of the internet.
So, how do you actually measure that kind of authority? Well, they engineered the PageRank matrix, and this brilliantly illustrates three ingenious mechanical steps. First, you have the structural pipeline, which measures the existing authority of the page linking to you, right? A link from the Stanford homepage carries immense structural value, whereas a link from my random personal blog carries almost none. Second is the dilution governor, and the math here is just elegant. If a high-authority site links out to 1,000 random places, its structural vote gets heavily diluted. But if it only links out to 2 sites, that value is highly concentrated.
That third step brings us to a specific equation metric called the damping factor. And this is where it gets absolutely fascinating. Page and Brin literally had to account for human behavior, standardly fixing this constant at 0.85. Basically, this mathematically simulates the probability that a human user casually clicking through hyperlinks is eventually going to grow bored, abandon their path, and just type an entirely new URL into the address bar. We've all done this, right? You click a few links, get bored, and just bail to a new site. By accounting for this human element, they took this highly subjective, invisible concept of prestige and converted it into cold, hard, unerasable code.
Section 2. Building the machine. Project Backrub.
To actually compile the raw dataset for that PageRank matrix, they needed hardware, but they had absolutely zero money. So they got incredibly scrappy. They hand-coded a multi-threaded HTML crawler that was intensely data-hungry. And to store all that data, they scavenged discarded hard drives right off Stanford's loading docks. They literally built a 1 terabyte storage vault housed inside a custom chassis made entirely out of colorful Lego bricks. I mean, you can't make this up. This scrappy little machine ran with such continuous intensity that it routinely consumed all of Stanford's bandwidth, completely paralyzing the university's IT network.
All right, Section 3, the Silicon Valley blind spot.
By the summer of 1998, they hit a severe hardware resource crisis. It forced Page and Brin to pause their dissertations and actually go shop their search engine around to establish tech monopolies. Their asking price? $1 million. That was the shockingly low buyout valuation they offered for the entire Google engine, the patent-pending PageRank algorithm, and all of its internal source code. And the corporate boards of legacy portals like Yahoo and Excite, they flatly rejected it. No way. So the crucial point is, why on earth would they reject a vastly superior product? Well, it came down to a total clash of business models. The 1998 corporate strategy was built entirely on keeping users trapped inside a portal to maximize ad impressions, maximizing stickiness.
Google's algorithm was the exact opposite, high-velocity routing designed to exit users to their target destination instantly. An executive at Excite literally rejected Google because it was, quote, too efficient. The industrial titans of the day actually wanted an engine that was slow and cluttered. They were structurally incapable of understanding the future of information.
That takes us to Section 4, Seeding Venture Dominance, the Garage Era. That brutal rejection actually forced them into the arms of venture capital. In August 1998, they managed to score a meeting with Andy Bechtolsheim, the co-founder of Sun Microsystems. He listened to Larry Page explain the matrix mathematics for maybe 10 minutes, intuitively grasped the monopoly potential right then and there, and casually scrawled out a seed check for $100,000. The grand irony here? He made the check out to Google Inc., which was a company that did not legally exist yet. So the check just sat on Larry Page's desk for weeks because they couldn't even open a commercial bank account to cash the thing.
Once they finally incorporated, they packed up those Lego server racks, exited the Stanford campus, and leased this crude concrete garage from Susan Wojcicki over in Menlo Park for $1,700 a month. And from this primitive, suburban outpost, they just went into absolute overdrive. They dropped hacked Linux servers directly onto the concrete floor, pulled in high-speed T1 internet lines, and shared this tiny flat table space right near the garage parking tracks. They were literally writing code from inside their sleeping bags just to survive the freezing winter nights.
But man, did it pay off. This absolute high-velocity optimization quickly caught the attention of Santel Road. By June 1999, backed by the sheer output of that scrappy garage operation, they secured a monumental $25 million joint financing round from Kleiner Perkins and Sequoia Capital. It is just wild to think about that leap, from freezing in a garage in sleeping bags to landing $25 million. That cash cemented their move to the permanent Googleplex and let them launch AdWords, this massive engine that monetized human intention based on explicit search intent rather than those old, useless static banner displays.
Section 5, the AI Continuum. From 1998 to Phase 7 AI.
Let's move to the modern era and see how this all builds, because we can draw a direct, unbroken mathematical line from those early 90s dorm room servers to the massive AI landscapes we're seeing today. We're really mapping the historical trajectory of knowledge compression. While the aesthetics of innovation have obviously evolved from hand-crawled HTML and Lego bricks to deep learning transformers and automated neural networks, the underlying logic of informational gatekeeping, that remains completely unbroken across these three eras. The ultimate technical bridge linking classic search indexing to modern artificial intelligence was actually engineered right inside Google's own research division. Back in 2017, their scientists published this absolute landmark paper called Attention is All You Need, which invented the transformer architecture. Basically, this replaced sequential data processing with automated mathematical attention mechanisms. It allowed computers to analyze the structural relationship between words globally and simultaneously. When you really look at it, this is a direct, conceptual evolution of PageRank's citation weight mechanics, just applied directly to human language semantics.
And that brings us to where the real threat lies today. Generative AI models, what some call Phase 7 cognitive systems, are threatening Google with a radical interface inversion. Consumers are abandoning that classic list of blue links because they want instant, unified answers directly from layered neural networks. These new AI models are threatening to completely disrupt Google's core business using the exact same reductionist philosophy that Page and Brin unleashed against legacy portals back in 1998. It's a total full-circle moment.
But obviously, Google isn't going down without a fight. They've deployed their proprietary tensor processing units, or TPUs. These are specialized custom chips designed explicitly to accelerate neural network matrix multiplications across their massive planetary data centers. Google uses its massive global index to feed its own frontier AI models, and it proves that nearly 30 years after that little Lego server, commanding the primary dataset of human history is still the ultimate, unassailable edge when you're engineering the cognitive machine.
Which brings us to a really provocative final thought. Larry Page and Sergey Brin broke the ancient tyranny of unstructured information by treating the entire recorded output of humanity as a single mathematical matrix. So if a math equation running on a scrap-built Lego server fundamentally rewired human history once, what will today's planetary-scale neural networks rewire tomorrow? I really want you to ponder the ultimate destiny of a global technology engineered by pure abstraction. Thanks for joining me for this explainer. Keep learning, and I'll see you next time.